Hello everyone, welcome back. So in this video, I'm going to introduce you to NumPy. NumPy is another very important library in Python. NumPy stands for Numerical Python. So it's going to be a library that brings with it a large number of methods to do numerical computations, to do analytics with it, to wrangle your data. So along with pandas, NumPy together, actually, we will be able to do quite a lot. So numerical Python, there is plenty of documentation. I'm going to share with you this link, and I've opened it here on the side. Well, I went into the main page where you can see a getting started, a user's guide. If you take a look at the getting started page for NumPy, it will take you from the ground up. So you can go in here, and then there is a user guide where you will find a lot of tutorials, and I recommend you go there as well. So here I'm going to give you an introduction, right? So the introduction will begin by first importing NumPy, and the name of the library is NumPy, N-U-M-P-Y, and normally we do as NP. So as we use it, we're going to use the abbreviation NP instead of having to type NPy. And I'm also going to import matplotlib because I'm going to be using some plots. And in this case, I specified is py plots, but I could have imported the entire library. So this is for the example here today, right? And the first thing I'm going to do is explore the library NP NumPy. I already imported it. It's already NP, right? So let's explore it a little bit. And I'm going to scroll down so you can see some of the methods that are built in the NumPy. Here, absolute numbers, add, there's some arc cosine, trigonometric. So it's a lot of mathematics that you can do with it. So it's pretty large. I'm only in the letter C right now, and I'm still scrolling down. So I'm going to show you some of these methods in this introduction. And then as you move forward, as you do more Python programming, you're going to discover new ones. So the first thing we're going to do is, before we create NumPy, ultimately, we will be using a NumPy array, which is another data structure, similar to lists, but not lists because this is numerical. Python and lists have other properties. So these NumPy arrays that I'm about to instantiate will bring with them the methods that belong to NumPy. So I'm going to demonstrate that in the flexibility that you get from NumPy. So, but I'm going to do it based on two lists. Remember, I used in one of the previous videos an example with scores. So somebody took a test, they took the first test, and all my students got all these scores, and then they took a second test, and then they got all these other scores. So I'm going to put them in a list first and foremost. So these are just plain lists. And how do you know if they are plain lists? Because they are within the square brackets, remember? So anytime you see, let's get you a pencil. If you see the square bracket, and then something, comma, something, comma, something, that is going to be a list in Python, all right? So I just instantiated these two lists. And the next thing I'm going to do is use those two lists that in turn will instantiate my my NumPy objects. So I will do that by running the .array method in NumPy, and I'm going to pass to that method a list. And I'm going to do two of those, so I'm going to have two NumPy objects at the end. So I'm going to do them here in the same cell. SC1, I'm going to call score1, SC1 to my first NumPy array, and SC2 to my second NumPy array. So here we go. So let's see the type of SC1. Obviously, the SC2 will be the same. So it's a NumPy that in the array, that's how it is described. So it is, again, it is a data structure that carries with it many methods. So let's take a look at some of the methods. One of them is mean. So I have a lot of statistical methods. So the mean, which is the average. So the average of the first list, let's scroll up a little bit, this first list that I have right here, the average of such list is 85.7. The average of the second list is 88.2. And I can do other fancy statistical, so the correlation coefficient, how are they correlated? And this is not a statistics class right now, right? But as you advance in your studies and do data science and machine learning and all that good stuff, you will be adding statistics to your repertoire of knowledge. So let's do this. So I see the correlation coefficient matrix, and you can see that I can pull up the numbers, 64.9%. All right, so that's the correlation coefficient. And the point that I'm trying to make here with the NumPy is that we can do run all kinds of methods associated that belong to the NumPy object, to the NumPy class. So now we also can do operations. So like I was saying, right, the NumPy is a data structure. So the first NumPy array that I have is SE1, and then I have SE2. I can get a specific number from it through an index value, and they start with 0. So SC14, for instance, what is that? That's 91. So if I go back to my list, right, I have 0, 1, 2, 3, 4. So the fourth value, let me get you a pencil so I can highlight it nicely. The fourth value is 91. So this is SC14. What will SC10 be? SC10 will be the 91 over here. That would be SC10. So it's similar to the lists, except these aren't lists. These are NumPy arrays. All right. So now let's try something else, another property. Once I have my NumPy arrays, I can do math between them as if they were variables. So in this case, I'm going to add the two NumPy arrays and I'm going to divide it by 2. And that's going to be the mean of the two lists. So if I go do that, I do the mean, and notice it does the mean on a number by number basis. So the first is 91. If I go back to the list, well, let me put the lists here again. Let me add them right here. So SC1, so you have it in front of you, and I don't have to be scrolling up and down, and SC2, right? So I did the mean SC1 plus SC2 divided by 2. So it does it on a one-by-one basis. So the 91 that I got here as a result in my mean is the average of 91 and 91. Well, that's the same number. 91 plus 91 divided by 2 is 91. The next one, I have 84. You see 84. I'm going to highlight it with my prompt here. 84, and that's the average or mean between 85 and 83. If you add 83 plus 85 and you divide it by 2, it splits it right in the middle in this case, right? It's very, very obvious. It's 84. And so forth. It is true for the rest of my numbers. If I go to the last one, 79 and 75, right? If I add 79 plus 75 and divide by 2, I get 77. 77. All right. So you can do mathematics between them. You can add, subtract, and do all kinds of fancy stuff. Now, let's create a NumPy. And I can create a NumPy with another method of NumPy called line space. That's something that you're going to come across quite a few times, because the line space. I'll tell you what, let me do this. I see 10 minutes into the recording. I'm going to stop the recording right now, and I'm going to start a new one where I'm going to create new NumPy arrays using the line space and random arrays. All right, I'll be right back. And so this so far is your first video on introduction on NumPy.